Quadratics, page 14. We'll start with problem 4e. If v is the vertex, find the equation of the quadratic function with graph. We have 2 points given to us here. We have the vertex, and we have 1 point here, which is not the intercept or anything. It's just a kind of a random point. Since we have the vertex, we probably want to use the vertex form y equals ax minus h squared plus k. Remember, h and k are the coordinates, x and y coordinates of the vertex. So we already have most of it. We have x minus 2 squared plus 3. And let me make that a better 2. And now we just need to know a. How are we going to figure out a? Well, they gave us this extra point, 3, 1. If we put in x equals 3 and y equals 1, then we're going to be able to figure out a. So we'll put 1 in for y, and then 3 in for x. And what do we get? 1 equals, and this will be 1 squared, so it'll be a plus 3 equals 1. A equals 1 minus 3, which is a negative 2. Does that make sense? Yeah, a is negative, so the parabola opens down, and it really does. So we have the equation negative 2, x minus 2 squared plus 3. And since they never said that we need to put in standard form or anything, then this is fine the way it is. Okay. Now it says, without using technology, find the coordinates of the point of intersection of, and it gives us the equation for a parabola, and it gives us the equation for a line. If you look at the example right above, it says how we can do that. Basically, we need to find the point x, y, which satisfies both equations. And the easiest way to do that is, okay, let's set y to be the same. So we could say that this y is the same as this y, and then we're going to just set these two equal to each other. Can you see where they did that here? They just took this quadratic equation and this linear equation, and they just set them equal to each other because the y's are going to be the same. And so when y is the same, what is the x going to be equal to? And they found 2 possible points. So we're going to do the same thing. We're just going to set x squared minus 2x plus 8 equals x plus 6. And so since they said without technology, we're going to do it with algebra. So let's see. Let's subtract x from both sides. That'll move the x on the right to the left. Let's subtract 6 from both sides. That'll move the 6 on the right to the left. So the right side became 0. The left side became x squared minus 3x plus 2. And so now we have a quadratic equation equal to 0, and then we just need to find when that's true. We have a number of ways to do that, factoring, quadratic equation. Let's try factoring. That doesn't work. We'll do the quadratic equation. So the whole number factors of 2 are 1 and 2, so that's our only possibility. And multiply negative 2 to negative 1 together, we'll get positive 2. That works. Negative 2x and negative 1x added together are negative 3x, so that worked too. So this is almost the answer. So now when is this true? Well, x minus 2 is equal to 0 when x equals 2. And x minus 1 equals 0 when x equals 1. So those are the 2 solutions for x. And find the coordinates of the point of intersection. So we found x equals 0. We found x equals 1. Now we just need to find the point of intersection. So how do we do that? Well, it's easier to put this 0 into the linear equation because the linear equation doesn't have any squares in it, so we'll just put 0 plus 6. So the y coordinate of this x is going to be 6. And the y coordinate of this x is going to be 7. Okay, so our two coordinates are 0, 6 and 1, 7. All right, and you could also have taken x equals 0 and x equals 1 and substituted into the original quadratic equation. That would give you the exact same answer because these points are on the line and they are also on the parabola. Now what you can't do is plug it back into this quadratic equation, which is a combination of these two quadratic equations, because if you do that, you're just going to get 0 because we were solving for 0, remember? So that's how you do that problem.